Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Welcome to an interactive journey into the world of forces, where you'll explore how different forces work in real life situations. In the simulation, you will push, pull, attract, and repel everything from closing drawers to rubbing balloons. Each scenario will give you the hands-on feel for forces that can shape our everyday experience. So let me open force and pressure simulation for you. Each simulation begins with a game plan. This outlines the learnings and the procedures of the simulation. If you are a new user, kindly go through this section thoroughly to maximize your experience. The main objective of this simulation is to provide an immersive visual representation of various types of forces using real-life scenarios. Our overall goal is to enable a better understanding about the forces. Here we have 5 important parts in this simulation. Before getting into the concept, I would like to show you the whole 360-degree view of our physics lab. By using your mouse cursor, by click, hold and drag, you can view that in different angles. Or else, you can click on this bottom right corner 4 buttons to view that in 4 different angles. F for front view, R for right, T for top and L for left. Let's get into the concept. The first concept we are going to deal is push and pull. So here we are going to understand how the force required to move an object changes with its weight. Let's start by having students interact with a simple scenario, a drawer. As weights are added to the drawer, the amount of force needed to close it increases. You can guide students to experiment by adjusting the force with the slider on the right. Let's see how it works. With an empty drawer, I'm going to apply a small amount of force, let's say 4 newtons of force, to close it. For closing the drawer, you have to click on this close the drawer button. It is closed well. Let me open it and add 10 kg of weights into the drawer. Let me apply same amount of force and try to close it. It's not enough to close the drawer. So what we have to do? We have to increase the force and then try again. So now I'm going to increase that to 10 newtons. Let me open it and try to close it again. It is closed now. So what about I'm increasing the mass? Let me open the drawer and I'm going to add extra 50 kg of weight inside the drawer. I'm going to apply the same amount of force, that is 10 newtons, to close it. It is not able to close the drawer completely. So what we have to do? We have to increase the force. Let me open it and increase the force up to, let's say 40 newtons and try again. By increasing the force, it would able to close it, but it's not completely closed down. So you can use the slider to increase the force and try to close the drawer again. Similarly, you can try out with different weights by adding 100 kg of weight, or else you can open the drawer by taking out the weight by placing 100 kg of weight and checking how much force is required to close the drawer completely. This part of the simulation teaches the students the relationship between mass, force and motion, and also reinforcing the concept of Newton's first law of motion. It encouraged them to play with the weight and force sliders to understand how these two variables affect each other. Let's move on to the second part of the simulation, that is magnetism. Here we have two parts, power of magnet and repulsion and attraction. Now let's understand the power of magnet. Here we have a small magnet and some big nails, small nails and paper clips are arranged over here. Let me move the small magnet towards the nail. Let's see how much it can attract. Using the mouse cursor, by click, hold and drag, you can do this dragging part. As you can see, it can attract a little amount of nails and paper clips. I am going to change the size of the magnet to medium. As you can see, it attracts more than before. What if I'm increasing the size of the magnet to large? As you can see, it is attracting more amount of particles than before. It clearly mentions that as the size of the magnet increases, the magnetic attraction grows stronger, which pulls more number of particles. Let's move on to pole interaction. Let's understand repulsion and attraction. Here we have two magnets, and the magnetic field and the field line is given using the compass. I'm going to bring the second magnet towards the first one, which is the left one. Let's see how the magnetic pole changes. As I am bringing it towards it, it creates another magnetic field line. As I am moving it closer to it, once I release the mouse button, it repels. Why it is repelling? You can ask your kids to answer this question. It is repelling because of the same pole. So let's change the pole of the magnet and try the experiment once again. As I'm moving it to the another magnet, even after I'm releasing the mouse cursor also, it is there with the left side magnet because this opposite pole attracts. This segment visually reinforces the concept of magnetic field and the magnetic poles, making the abstract idea of magnetic attraction and repulsion tangible. Let's see the third part of the simulation, that is electrostatic. Here we are going to demonstrate how electrostatic forces cause objects to repel or attract each other. Here, students will engage with static electricity using a fun everyday example, rubbing a balloon on a cotton cloth. Here we took woolen cloth and two balloons. Let me take green one where the electrostatic charge, the graph shows that is 0. Let me take that and rub it on the woolen cloth. As I'm rubbing it, the graph shows that its electrostatic force is increasing. Once it reached the end point, it becomes red color. Let's see what happens if I'm bringing the green one towards the red one. Red one, which is having almost 0 electrostatic charge. As you can see, it attracts each other. Now, let me take the red one and rub it on the woolen cloth again. Now, both the balloons are having electrostatic charge. Let's see what happens if I am bringing close to each other. It repels because same charges repels and the opposite charge attracts. This experiment brings the concept of electrostatic forces to life, showing the students how everyday material can acquire and interact through charges. It is a playful yet informative way to understand how like charges repel and opposite charges attract. Let's move on to the fourth part of the simulation, that is gravitation. Here we are going to explore how gravity varies on different celestial bodies and how it affects the motion of the object. Here we have the gravity of Earth and Mars. Let's start by dropping an object on Earth. Student will see the object fall at the usual speed, that is because the gravity is 9.8 meter per second square. Let's watch the Mars. Here the gravity is 3.71 meter per second square. Due to less gravity, the drop of the balloon or the ball is less in speed. Let me use the mouse cursor to change the celestial body to Moon. Here I am having the gravity of less than Mars, that is 1.62 meter per second square. So as I am comparing Mars with Moon, the ball falls faster in Mars than Moon. Finally, let's try dropping an object in an outer space where the gravity is absent. It causes the object to float freely. It's not falling also. This simulation vividly demonstrates the concept of gravitational acceleration and helps the students to understand how the strength of gravity affects the object in motion on different planets. Finally, let's wrap the lesson in the quiz. You can engage students with the quiz that asks them to categorize the real-life examples to contact force and non-contact forces. Here I have one man walking a dog, pole vault, kick a ball, football players, and high jump, swing, and much more. Just using your mouse, drag and drop on a particular box, you can complete this quiz. We put leaf falling from the tree as a non-contact force. Like a fur, water drops. I'm filling it randomly to show how this quiz works. Once you have drag and drop all these answers, you can click on this submit button to know the answer. Upon clicking on submit, it is showing the answers are incorrect. Please correct them and resubmit. Or else you can click on view answer button to view the answers. You can see the football, man is going walk with a dog, swing, all are contact forces, and the non-contact forces are leaf is falling from the tree, high jump, pole, and everything. In this interactive simulation, your ticket is to exploring the invisible but powerful forces around us. Whether you are pushing the dryer, dropping a balloon, experimenting with magnets, or observing the gravity on different planets, your students will gain a deeper understanding of how forces shape our world and beyond. Thanks for watching.